Hey Calc class. So today we're going to talk about something called a u-substitution. And a u-substitution is basically taking the antiderivative when you had our chain rule to start with, right? So think about that chain rule and what happens when we do that, when we take the derivative. Now we're going to have to go backwards. All right, so pause the video and try to do now. So because it's a piecewise function, we're going to go from, put the pen on, -2 to 2. So -2 to 2, x plus 3, dx. And then 3x dx from 2 to 10. All right. Now, if you really want, you can like draw a triangle and find the area of the triangle, but I think that's too much work. So x squared over 2 plus 3x from -2 to 2. So let's see, that's 2 plus 6 minus 2 minus 6. And then over here, well, let's see, the 2's cancel, so 12. And then over here we get 3x squared over 2 from 2 to 10. So that's 100 divided by 2 is 50, times 3 is 150, minus 6. So that's 144 plus 12, 156. So C. That's it. Okay, so indefinite integral is where we use that C. We've talked about that in the past when you have that extra constant. So anytime we don't have bounds, we put plus C. If we don't put bounds, then we did I just make any kind of sense? When we have bounds, we plug in and we don't need the C. When we don't have bounds, we put the plus C, right? Indefinite. We don't know what we're integrating over, right? I don't know where my area is. So it's creating that function that is the antiderivative. Okay, so find the following indefinite integrals. So pause the video and do these. So this is x to the 5th over 5. Again, we're not plugging in, so we put our plus C. This is the integral of x to the 1/2. So that's x add 1, divide by the fraction or multiply by the reciprocal, plus C. This one's a little tricky. You got to rewrite it. What do you get here? So this is actually sine x over cosine x times 1 over cosine x, which is tan secant. Sorry, my rating is so bad. Whose derivative is tan secant, or we usually write it as secant tan? Whose derivative is that? That is secant, so secant of x plus C. So when you have these weird trig ones, you got to figure out how to rewrite it. We will spend a little bit of time practicing that. Okay, so now let's just do a quick review of the chain rule. So differentiate, find the derivative of each of those. So pause and do that. So we start on the outside, bring it down, and then, oh my gosh, the derivative of the inside. There we go. That was a terrible handwriting. Let me fix that for you guys. Sine x. All right, g prime. 8 comes down, inside stays the same. Down by 1, and then times derivative of the inside, 8x. H prime. Outside is our square root. Derivative of the square root is 2 times that square root. Derivative of the inside goes on top. Okay, so we are going to be doing the reverse of this. So let's take a look at this. Like, take a look at each of these and think about the pattern. We have we have a derivative present in every single one of these, right? Sine was a function. Its derivative is cosine. 8x is the derivative of this inside. 2x minus 8 is the derivative of this, right? So notice that when you're doing a chain rule, you always have that derivative present. So if we were to go backwards, what happens to the derivative? It ends up disappearing. That 8x goes away, right? 8 goes up, divides out, and then we have that derivative that we multiplied by has to disappear somehow, right? So we have a function that's going to have to disappear. All right, so a u-substitution is a method in which we replace the inside function of a composition with u in order to create an integrable function. So all of these functions are not something we can multiply out to simplify. Okay, so we're going to start by identifying our inside. This is a composition, right? So we have the composition, we have an inside and an outside, and that's why we use the chain rule. So we always let our u, we're going to let our u equal the inside function. In this case, x squared plus 5. Now we're going to differentiate because remember we have that chain rule that happens. So the derivative of u in terms of x, notice there's x in the problem. It's not u prime, we're going to do du dx equals 2x. Right. Now what we're going to do is, this is a little weird. We have du dx. We're actually going to multiply both sides by dx. So du equals 2x times dx. And then we're going to solve for dx to get dx by itself. So I'm going to divide by 2x. Right. So dx equals du over 2x. All right, so now what we're going to do, so we decided our inside, right? I took my inside, and then I differentiated and solved for dx. So these are the two things that are most important. We are now going to make a substitution. I'm using the highlighter. Whoopsies. I thought it looked weird. Let's erase that. All right. So I've got the integral. The 2x is staying. We're not going to do anything with that quite yet. Now I have my parentheses to the fourth. But what is x squared plus 5? That was my u. Right? So I'm going to plug in my u, and I'm going to replace dx with what dx equals, du over 2x. Now, at this point, the x's should cancel. If we did this correctly, I have this 2x and this 2x cancel out. So now I only have u's in my problem. Okay. That I know how to find the antiderivative of. So the integral is u to the 5th over 5 plus c. Now, and then lastly, we're going to replace our u back in. So what does u equal? X squared plus 5 to the 5th all over 5 plus c. And we are done. Now, if you want to check your answer, you can take the derivative. Right? So the derivative of bringing the 5 down front, inside stays the same, goes down to 4, times the derivative of the inside. Oops, x squared, 2x. Ugh, what is wrong with me? You guys are like, oh, you always make mistakes. And notice this is what we started with. So I figure out my inside, that's my u. I take the derivative of both sides and solve for dx. Substitute, your x's should cancel. If your x's don't cancel, you did something wrong. All right, so take a minute and see, what do you think your u is? And then take the derivative of both sides and solve for dx. So u is pretty much always the inside function, right? Because this is based on a chain rule. So my u is my inside. The inside here is x cubed minus 4. Take the derivative of both sides. Du dx equals 3x squared. Multiply by dx on both sides. And divide. I make a substitution. I'm going to replace my dx, and I'm going to replace my u. Right, so u and dx get substituted in. So 6x squared is staying. I don't do anything with that outside function yet. Sine of, now I'm replacing my inside with u, and then replacing my dx. At this point, my x's, any x's left over should cancel out if I did this correctly. And it does. So the x squareds go away. And then I can also simplify. 6 divided goes into 3 twice. So I have the integral of 2 sine of u du. Now I can take my antiderivative. Antiderivative of sine is negative cosine. So negative 2 cosine of u plus c. And then I'm going to substitute back in for my u. And that is our final answer. All right, a little more challenging. So try this. See if you can figure it out. This is definitely a challenging problem, though. So what would our inside be in this case? The inside is the inside of our exponent, right? The square root of x. What's the square, and then what's the derivative? So 1 over 2 root x. So dx is 2 root x du. Yet again, a good reason to have that memorized, that the square root of x is 1 over 2 root x. Now, here's what's difficult. What are we substituting back in? This is what a lot of kids do. They say, oh, it's e to the u over u 2 root x du. That's wrong. Why is that wrong? Well, the square root of x didn't cancel. You can't integrate unless you only have u's in the problem. Because this is a du, you can only have x's. So I put an extra u in. Where do I not want a u? This dx is on top. I need that root x in the bottom. I need this root x down here. We're not going to replace it so that the root x and root x cancel. So then I have the integral of 2 e to the u du. Antiderivative, 2 e to the u plus c. And then we make our substitution back in. And that's our answer. And here's how I think about it. I mean, I know that the derivative of my inside needs to be present. What's the derivative of the square root of x? 1 over 2 root x. So the 2 root x in the denominator is the derivative of our inside. So we needed that somewhere in the problem. And so that 2 came up. You can't just magically put a 2 in the problem. So you put a 2 on the bottom, you needed 1 on top. And that's where that extra 2 came from. All right, last one. Here's a hint. Start with a substitution. Not a u substitution. What do we know equals tangent? Because no one's derivative is tangent that we know of. So the first thing we're going to do is make a substitution. What do we know tan equals? That's our sine x over cosine x. Now, here's the thing. The derivative of sine is cosine. The derivative of cosine is negative sine. So, is your u going to be the top or the bottom? So try it out, see if you can figure it out. I'm going to show you the wrong one first, all right? So this is not going to work out. So I'm going to show you why it doesn't work. All right, if you try to let u equal sine x, du dx equals cosine, So then dx equals du over cosine x. So when I make that substitution, u over cosine, du over cosine, the cosines don't cancel, they multiply. You end up with cosine squared, and that's not helpful. So a good rule of thumb, it doesn't work every single time, but if you have a fraction, a lot of the time, your u is just the denominator, right? Again, I wish I could say it was 100% of the time, but it's not. But it's really, really common for the denominator to be our u. So u is cosine, negative sine. So dx is du over negative sine x. So that when we make our substitution now, sine x is on top, your u is the bottom, du over negative sine. So now the signs cancel. So negative 1 over u du. Whose antiderivative is 1 over u? Careful there. That's an ln. So it's negative ln of u plus c, negative ln of cosine. You'll notice that I put absolute value. I haven't really brought this up yet, but when you take the antiderivative of 1 over u, you got to look out. You really are supposed to put an absolute value. Because here, you can plug negatives in, but if you get a negative from this, you're not allowed, you can't plug a negative into an ln. So that's why you have that absolute value there. All right, so let's practice 21 through 28 all. This is challenging. We're going to spend a whole week on this, like 3 class periods on this because it is important and I know this is challenging.